video, we're going to be talking about energy. Energy is the ability to do work. We can define energy as power times time. We can then take power as energy per time, and that gives us the rate at which work is done. Okay, so power is energy per time, and so that gives us a rate at which work is done. We can measure energy with a couple of different units. There are a couple units that you should be aware of: joules, BTUs, and kilowatt hours. Joule is the energy it takes for 1 watt of electrical output to be turned on for 1 second. A BTU is a British thermal unit. It is the amount of energy it takes to heat 1 pound of water, 1 degree Fahrenheit. And a kilowatt hour is the amount of energy expended for using 1 kilowatt for 1 hour. And we also need to add calories in there. And now there's 2 different types of calories. There is the little c calorie and there's the big C calorie. So a big C calorie is a kilocalorie. So a small c calorie is the amount of energy it takes to raise 1 gram of water, 1 degree Celsius. So a big C calorie is 1,000 little c calories. The calories that you see on a food label is going to be a big C calorie or a kilocalorie. Some countries will use big C calorie, like the United States. A lot of places here in Europe actually uses kilocalories instead of using the big C calorie. Just to give you some conversions, 1 calorie is 4.184 joules. 1 BTU is 1,056 joules. 1 kilowatt hour is going to be 3,600,000 joules. So it's going to depend on the case of when you would use these measures of energy. Calories, like I said, is going to generally be related to food intake and output. BTUs, the place that we see that the most is with air conditioners. BTU is British thermal unit. So if you ever go shopping for a air conditioner, you might see it rated with BTUs of how many BTUs it uses as energy. Kilowatt hour is generally done with your electricity. So when you're looking at how much electricity you've used, a lot of times it's done with the kilowatt hours. So you might see having to change between some of these units, converting between joules and BTUs or BTUs between kilowatt hours, that sort of thing. So be on the lookout for some math problems involving changing between these units. This form. So if you think about eating, we put the energy of it just changes form. So if you think about eating, we put the energy of the food into our bodies, and then we break that down into chemical energy, and then we expend it in different forms of energy. It could be in sound energy. The fact that I am making sound is a type of energy that's leaving. I'm also creating heat. So with all of the reactions of breaking down that food, I'm creating some heat. So I'm releasing heat energy. I might also be releasing some movement energy with my hands moving here as I'm talking. As my jaw is moving as I'm talking, I'm also releasing that energy through movement. Light can be a form of energy release. Heat tends to be one of the most common biological forms of energy transfer. So as we are looking at food webs and food chains, a lot of the energy is dissipated and released as heat. So energy can be chemical, it can be electrical, and it depends on the situation and the system that it's in, of how it goes in and how it comes out. The same amount goes in as the same amount comes out, which leads us to the second law of thermodynamics. So the second law of thermodynamics states that what goes in must come out, but the ability to do work diminishes. So essentially what that means is the amount of energy that goes into the system is going to equal the number that comes out. It's just not necessarily going to be the same form. So if there, let's say, is 10 joules going into the system, 10 joules will come out. It just might be 10 joules divided up into, let's say, 5 of one type of energy, 5 joules of one type of energy, and 5 joules of a different type of energy. That is just like a basic example. So the amount of energy goes in is going to be equal to the amount of energy that comes out. It's just going to be equal. And the other thing is that ability to do work diminishes with the energy that comes out. So the quality of energy that goes in is going to be different than the quality of energy that comes out. So if we're looking at a food chain, the amount of energy that goes into the plants, the amount that comes out, basically what we can get from it, it diminishes. So we're not going to get the same amount of energy that is going into the plants as that's coming out. And that's why our food chains can only be so big, because the amount of energy that's transferred is only about 10% of energy between each trophic level. And so the amount of work that's able to be done with the output is going to diminish. So when we're looking at the creation of electricity, the amount of energy that goes in to make that electricity is going to be the amount that we can make work from that electricity that's being produced is going to diminish. So when we are looking at energy, we need to take two things into account: efficiency and quality. When we're thinking about efficiency, we're thinking about how much energy we can get per unit of energy. The more energy we can get, the more we can utilize per unit energy, the more efficient it's going to be. And then overall, we'll be using less energy in our system for it to work. Energy quality is looking at how easy is it to use? How easy is it to transport from one area to another? How easy is it to get it to the item or being that you want to power? Is the food in the place where the people are? Is the energy source where you're getting the energy from where the items are that you need to power? How easy is it to transport from one area to another? So those are things that you're looking at with the energy quality. Open systems versus closed systems. Open systems are systems where energy is coming from the outside, going into the system, and then being released back outside the system. Open systems tend to be dynamic, allowing energy sources in from the outside, and then can change and grow, and then allow energy to go to other systems that are out there. So organisms, ecosystems are all open systems. Closed systems, on the other hand, may utilize energy from outside sources, but the matter stays within the system. The Earth as a whole is a closed system. The water cycle is a closed system. The water is just being transformed into different forms. And lastly, we're going to talk about feedback. Negative feedback and positive feedback. Negative feedback is when there is a baseline, and when something gets too high above the baseline, bring back to normal, or below the baseline, again, bring it up back to normal. An example of negative feedback would be with your own body. If you are getting too hot, your body temperature rises. Your body says, hey, we need to take care of this. So maybe you start sweating. Use the evaporative cooling to bring your body temperature back down to the baseline. When your body temperature gets too low and you're too cold, your cells start to shake, create energy, create heat to bring you back up, hopefully, to normal. So with negative feedback, there's a baseline, and when you get too high, you bring it back, and when you get too low, you bring it back. Carrying capacity could also be considered a negative feedback loop, because when the population gets too high above carrying capacity, there's not enough food and resources to take care of those organisms, so the population starts to die off. And then when you go below that carrying capacity, now there's enough resources so the organisms can rebuild, and there's this wavering around that baseline. You can consider homeostasis being that baseline for negative feedback. Positive feedback, on the other hand, is where there's an amplification for that response. So warmer, the ice starts to melt, which causes there to be less, which causes there to be more heat absorption into the ocean, because the dark color of the ocean comparatively to the light color of the ice causes there to be more heat in the ocean, which causes more ice to melt. Also, when the ice melts, it releases methane. Methane is a greenhouse gas. This greenhouse gas causes warmer temperatures, and it just keeps keeping on until we have no more ice to melt. So positive feedback is an amplification. Negative feedback is a baseline. And if you get too high, you bring it back. And if you get too low, you bring it back. Thank you for watching. This is Science with Armstrong.